root user out there when I'm using sudo user. For instance, let me log out here on the Kali Linux. I'm going to log in here as a sudo user. That is, username is Kali, password name is Kali. This is not a root user, right? So when I open my terminal, also you can see it is telling Kali is the user, but still I can log in as root user here. I can do sudo su root, and I'm not entering the root user password out here. I'm entering the Kali user password, and you see I can still do that. This is allowed. OK, you log in as a sudo user and then escalate privilege escalation to root. That is allowed out there, but directly connecting to root is very, very bad out there. OK, the main reason is when you do this process, the logs of any command that you're going to run, it is going to be logged, and someone in some cases you can have the alert sent to the SOC team as well, telling that a particular sudo command was executed. But when you log in as root user directly, it's a very easily we can remove those communications. We can filter out all those things. That is the reason we don't allow for that part. And one of the reasons why pen testing perspective, why web application is more important is web application is where the scanners are not good enough. The manually you have to be able to do it. That is when we identify a lot of vulnerabilities. Whereas network infrastructure like servers, firewalls, WAF and other things, configurations and scans are more than sufficient for them. In some cases we do pen testing, but still this is very rarely we get a compromise in a network infrastructure these days. Hope that is clear, Ganesh.
Okay, sir. Thank you, sir, very much.
So that is why I told you have to look at web application services as a very important component of that.
Understood,
Any
sir.
other questions? Any other questions, guys? Yes, Karthik. Yeah, please go ahead. Yeah, please go ahead. Yeah, we can hear you, Karthik.
Hello.
Yeah, Karthik.
Actually, I posted one in chat actually.
Yes, that is set to be no, right? For that. So you have to be a bit careful with that. Change the password authentication to no out there. So when you do set that instead of S to no, you will not be able to log in with the username and password. OK, that is what is going to happen. But you have to be very careful. The key should already be in the system out there before you making this configuration. If you enable this configuration without transferring your public key, you will be logged out. You cannot access anything in the server and probably you might lose all your data. So this is not a secure configuration, but you have to be very careful when you're setting this configuration in real time.
If yes means we have to provide the username and password for that one.
No, it is not mandatory. If there is a public key available, it will take with the public key. If there is no public key, then it will ask for the password for that. OK, for instance, in my scenario, I'll tell you one thing. For instance, here, if you remember, we have already created a file out there, right, and pushed it to the server. So what I'm going to do is that I'm going to create a new file, new public key and private key. Now, what is going to happen is that since that the public key is changed, it will not support the older key is not going to match here. So now it will automatically shift to password trace authentication. So I'll give SSH-EGEN-TRC4096. Yes, it is asking to override existing key. I'm going to give it as, and it is changed. So now the public key here is not going to match the Ubuntu, the public key that is there in the authorized files out here. So now if I try to connect, see here, it will ask me for password here. Previously, it was not asking because the authentication was there. It is going to ask for the password. I can enter it. But based on your communication, if you're checking out here, If I give it this as no, it will tell password key mismatch and it will give an error and close the communication. It will not ask for the password of that. So you have to be very careful. The key management is very critical. You ought by mistake, you make modification to your public key, you can say goodbye to the communication to the server of that. You will not be able to access it. It's very, you have to be very careful. Key management is very critical here. Okay. Any other questions, guys?
Sir, one more question, sir.
Yeah, Ganesh.
Sir, about the OSCP certification, sir. Where can I get its resources, sir, for free?
They will only give the resources. You can't get, I would not suggest going free resources for OSCP. When you enroll to the course, I think it is about $1,750 for that. They will give resources for that along with that, and they'll give you access to the lab for 3 months. So that should be predominantly good for you. But if you want to practice well before going into OSCP certification for free, you can either use Vulnup. There's a lot of missions out there. You can try your go at it, understand how the hacking process, how to get comfortable with using tools, right? So then once you're done with that, then you can go with the OSCP course. You cannot reduce the cost, whether you get a free resource outside or not. You can't reduce the cost. Okay. If you want to have a bit more quality, I would suggest Hack the Box. For practicing OSCP. OSCP is you have to pay for that 1,750. There's no way
No,
around
sir,
it.
the certification is too expensive for me. So where can I find the alternative resources to learn from OSCP?
You can try Hack the Box. There are certain Hack the Box Academy is there. You will be able to learn for a reduced price of them.
Okay, sir. Okay, sir. Thank you, sir.
Yeah, you're welcome. Free resources you can look, you will be able to get it. If you're able to good at Google, you should be able to get information for that. Any other question, guys?
Yes, there is where I was reading and I read something like SSS agent forwarding. Kindly, if you can explain to me what that means, because
I
it wasn't
didn't get
clear.
you.
SSH agent forwarding. Like there is where I was perusing about SSH and I saw SSH agent forwarding and okay, it wasn't clearly explained. So maybe if you can, yeah, explain to me if you have an idea.
SSH agent forwarding, you mean to say?
Yeah. Yes.
One second. Just give me a second. So it is, I'm not completely sure about this. So predominantly this SSH forwarding is something like storing your passwords in your browser, right? So whenever you're trying to connect to any website, if the password is stored in your browser, the password is automatically populated. You can select which password to use and then it will do the process. A similar process is that for this an agent component that need to be working out there and it will take care of that process for that, right? So this is predominantly for managing passphrases, and especially this can be used in a GitHub, Git process environment out there, right? But I have not seen being used it in real time that much, right? It may be some special cases this can be used in your situations, right? So instead of remembering, and that's how it goes. Yeah, Timon, please let me know.
Hello, sir.
Hi.
Hello, sir.
Yeah, please go ahead.
Good day. I'm interested in this program, but the thing is, I am totally lost here. I'm just listening. Is there any simpler class that I can start with?
I think I think Menon would like to answer that. So if you're starting off with our main course, we do start from very basic component out there, and then we'll finally come down to this component, and then we explain out there. That is also is going to be done. If you feel from an internship perspective, we are at the tail end of the internship program out here. So very soon we are going to restart the process where initially we talk about basics of cybersecurity, what are the things that is activities that are going to be there. So if you can join in those classes also, it will be a bit more easier for you to understand what is happening out here.
Thank you so much, sir.
Welcome. So Debasis, sir, can we start the DevOps? Are we starting now?
Hi, Karthik. Thank you very much. Somebody is asking some question. I think Timon is asking something.
Yeah, yes, that is completed. I think they have not removed their hand out there. That is completed.
Okay, fine. So we are basically then very good to start our DevOps session. I think, am I audible? I'm yet to be visible.
Yes, you are audible, sir.
Great. So let me start the recording first. Thank you, Karthik, for your wonderful session. Actually, it was mind-blowing.
Thank you, sir. Thank you very much.
And now it has always been a very, very difficult task for me after having such a wonderful session. It becomes really an uphill task for me to continue with that same tempo because it is a different subject and it is something else. So, and also it is difficult for the participants also to focus from one subject to the other subject. in a stress. I mean, at a stretch. So anyway, we will try our best. Let's see how far we can do. Today, I'm going to start with DevOps. Till this far, we have had few of the sessions regarding our introduction to DevOps, why we should be learning DevOps. Then we switched over to learning this cloud, AWS Cloud. There were 2 sessions on it. Then we learned about Terraform, again 2 sessions, and again there are 2 sessions of Ansible. Now today it will be the 8th session, which is on Docker. Let us understand Docker, because Docker is one of your very I mean the fundamentals of the main DevOps lifecycle or software development lifecycle, because it will ultimately, a product that you develop has to be deployed. So a product can be a Java application, it can be a .NET application, it can be any sort of application that you have designed. It could be a Python one as well. It can be a very complicated software, microservices. Okay. And you have developed, say, 25 microservices in a particular application, and you have to deploy them and you have to coordinate them in an orchestration such that they are basically available and they are deployed correctly. Okay, so all these things need a basic understanding, a very good fundamentals and understanding of containers, images. That is what we are going to start we will lay the foundation for our understanding from today. Okay, let us learn Docker. So let me share the screen. Let me know if you are being able to see the screen.
It's visible, sir.
Okay, and also I would like to start my camera. And I will go back to this topic where we will see. I hope the video is on and you are being able to hear me properly, so we can have a good start. I think all of you have heard about and have also worked and learned about Docker somewhere earlier, because this has been already 8 to, I mean, it's already 10 months that we have been with this particular program of internship, and out of which DevOps might have been repeated or recycled for at least 4 times. This is the 4th cycle, okay, of 8 sessions. So many of you are very much aware of what this topic is, Docker, but there are also new participants, new students who have joined us with the hope that they would like to have a basic preview of a container and the importance of learning this particular topic with respect to DevOps. See, why you learn DevOps is because you are going into an IT field where almost all your doors are closed. Like if you are planning to, you are coming from a non-IT background and now you are stepping into IT. Now, what you think is it will be very difficult for you to step into as a developer job, because the market is so saturated and there are so much expertise available that it will be very difficult for you to compete. So similarly, for any other field that you think, like the cloud administrator, the administrative jobs, database administration, everything is quite saturated. You will not be able to easily crack through. And therefore, the easiest and the best way to enter this IT field, and then you grow on that. It's like stacks or layers that you build around your knowledge, is start with DevOps, because that is the easiest entry into IT field. And once you are there, with the knowledge of, first of all, you have to have a very good knowledge on cloud. You have to have a very good knowledge of Linux. These are the stepping stones. These are the building blocks. If you are trying to build a nice building, nice house, you need to have your foundation very well done. And that foundation is on cloud, and that foundation is on Linux. You cannot say, no, I will straight away go to learn Ansible, Terraform, Kubernetes, Docker. I will say no. First, take the small steps, build your confidence over the technology, and then you go into this thing. So we have been doing all these things out of this 8 weeks or 8 weekends. We have been devoted this 7 weekends on learning cloud, the introduction to DevOps, cloud, and then the rest followed. Now we are on the 8th session trying to learn about Docker. So it is very important to understand this particular topic. Let me make it full screen. So before going to the Docker, let us learn about container. I mean, not before or after. It is, container is an integral part of your knowledge when you try to build on the concept of Docker and containerization. So container is an object. Okay. A container is a standard unit of software that packages up code. So whatever the code is being developed by the developers, now they are trying to, you will be helping them to put that entire code. Maybe there are hundreds of Java files. Now, how will you? And so deployment becomes a big headache for any development team. Okay, how they are going to, and because it does not depend on the development team only, because there will be the testing team, and after the testing team, there will be the the deployment. I mean the operations team, that they will take the entire code from the test server to the pre-production, from the pre-production to the production. Now, all this stays from the development stage to the testing stage. You are deploying the big bulk of code that was developed by the development team. It is not an easy task if you do it manually. Earlier, before the containerization came into market, it was all done manually. And therefore, there was a lot of hiccups. There was a lot of issues. It would have, nowadays, you will take not even 1 hour to deploy a big package. But earlier, it used to take maybe weeks to deploy that software, which you could now deploy within 1 hour. And in fact, Amazon deploys almost every 16 minutes, as per the statistics, every 16 minutes, they either deploy a new package or some software upgradation or modules. They keep on deploying every 16 minutes one. Can you imagine? And that was possible because you have this technology, container technology. So it is like you are building an environment with all the dependencies for the software to run within that particular container. All the dependencies will be inside that container. You do not need to go here and there. You do not have to run from this place to that place to get help from the environment. No, you do not have to depend on any platform. It is that unique in nature. So you just package your code into a container environment, and then you can quickly run your application from one environment to the other environment without any change or modification to any other thing. So it is platform independent. In the meantime, when I am trying to explain it, please, whenever you are getting stuck somewhere, please let me know if you are not understanding, and you can unmute yourself and please let me know. That will help, because I'm just seeing my screen in front of me. I cannot see whether you are raising your hands or whether you are writing something in the chat box. I cannot. So please raise your voice. Okay. Then comes the images. A container is a container by the name itself. It's a container. It's a sort of a bucket in which you put something. And what is that something? That something is the image. You build the image out of the code, out of the source code that has been given to you by the developers. So it is like 20 Java codes, Java files. What you do, you build them as an image. And once you have done that image, you put that into a container, or better to say, image is a static object. Container is a dynamic object. So an image cannot run without a container, and container has no meaning without an image. So you cannot create an empty container. You cannot create an empty container. You have to have at least one layer of image within that container, at least the base image. Then only the container will take its shape. Are you getting me? And then to run that container, you need to have some engine, some containerized engine, or containerd, which may be Docker. Docker is one of the softwares which is very, very popular. So like you go to ask for a particular, like you go for buying an electric bulb, and Philips is so well known in this market that you are saying, please give me one Philips. The seller will immediately know that you are asking for a Philips bulb, LED bulb maybe. So it is like that. So whenever you are trying to say anything about container, Docker automatically comes in. But it is not only Docker. There are several other providers of this containerization technology. Is that clear? Any question? But Docker is so famous, and Docker comes inbuilt with so many packages. Docker already comes in, but it is better if you configure, install Docker yourself into your environment, because when you are working on a Linux, it will be better that if it may come with inbuilt Docker engine, but better you do the engine, or you create that engine, or you configure that engine fresh from your end. Okay. So it is available for both Linux and Windows. It is not only for Windows. It can be Linux, Windows, and Mac. Docker is available in all the three platforms. Containerized software will always run the same regardless of the infrastructure. Now, this is the internal architecture of a container. Everybody, can you see the image? Is that image visible? And you can see the layers?
Yes, sir. Yes, sir.
Yeah, good.
Yes, sir.
So, yes, very good. So you see, it's a very interesting thing, very interesting subject, because if you know this part, deployment becomes very easier for you. You understand what you are talking about. Whenever you see, when you are in an IT project as a DevOps guy, DevOps engineer, you need to attend so many meetings, so many stand-up calls. You are an integral part of the project. Okay, you have to communicate with your testers, with your developers, with your operations guys, with your project manager, with your everyone. Okay, so you have to be aware of the terms, and unless and until you understand those meaning of those terms and what they are talking about, it will be very difficult for you to. You will get a job, but it will be very difficult. You will not be impressive. Okay, so understand what we have an objective, not only to get a certificate. Certificate does not do anything for you. It is no good unless and until in an interview, interviewer will be very impressed. You will get an interview call because of your certificates, but that does not guarantee you that interviewer will be making a pass. You will pass that interview. You will crack that interview. To do that, your certificates will not come to any help. It is only your knowledge. Okay, The little bit of things that will make the difference. Many people know Docker, but on a very superficial level, on the outer level. So they get stuck. And the interviewers are very intelligent, they can easily understand that you are trying to fake a question and answer, fake an answer. You are not very confident with that answer, but you are trying to just make a fool of that interviewer, but you cannot fool them, because they will, within 5 minutes, they will understand that whether you know or you do not. It is binary, yes or no. There is nothing in between. So let's say the container is like, you have seen the containers in the cargo ship. You have seen definitely cargo ship. Okay, and there you will see or maybe in the cargo trains. Okay, the cargo trains. In India, we see a lot of cargo trains, and there you will see a big containers getting ported from one port to the other port. Okay, similarly in the ships also you can see the very large container. Exactly the same concept, and that's why it is called Docker. Dock means shipyard. Okay, and the containers are docked in the shipyard for transporting something, and that something is the image. So these are this is the outer layer of the container, thin writable layers on which you will write the image, or you will put the image layers. So it is like this. One container will have a Docker image inside it, and that image can be composed of so many layers, one after the other. Okay, one after the other, there are layers. And now you can ask me, Debashish, what is this layer 1, layer 2, layer 3, layer 4? Nothing is. The layers are a software. Any software that you get or pull from the Docker hub. Or hub is something, a place, a repository where you store your images. Like in GitHub. What you store in a GitHub? Can anybody tell me? What is GitHub meant for? To store what?
Source code.
To store the source codes, like the Java codes, the Python codes. That is the place where you deal with the code part, or the files. You store the files. But here in Docker Hub, you store the Docker images as image. These are not ordinary files. These are Docker build images, or basically the images. It can be built through Docker. It could have been built with some other, like Mesos or Rocket. Okay. So this is one layer, represents one software. Another layer on top of that is another software. So let's say the pink ones are the images. Ubuntu is what? Ubuntu is an operating system. Okay, so that will see, any software will run over, any application will run over one operating system. At least a lightweight of that operating system. The minimum libraries and binaries that are needed to support the running of that application is the operating system. So you must, for any image, it's not necessary, but generally your application cannot run on its own. So you need to package that application along with the operating system. So you always recommended that when you build a container, the image, the first layer of the image should be the base image of any operating system. It can be Ubuntu, it can be Windows, it can be Mac, it can be Red Hat, it can be SUSE, it can be Fedora, it can be CentOS, any, you name it. Okay, it can be BZB. So doesn't matter what the base image is, it has to be any operating system on which your application will run. So once you have done that base image, comes the another layer, the layer 2, let's say. So you have maybe instead of Emacs, you have installed some middleware, some business layer, some software, maybe some software, and which will be acting as a middleware. Now, on top of it, another image that you have installed is maybe a web server like Apache. That web server has been installed. And on top of Apache, you might be installing Java compiler. So that is another layer, the fourth layer. So first layer, second layer, third layer, fourth layer is the Java compiler. And maybe on the fifth layer, you will add all the source code, the Java source code, which will be running on that, which will be compiled as a Java executable. So you are building up a container within which you are building up all the layers of software to support your application. Up to this point, any question? No question, right? So it's very simple that you are building up your container with images layer, the image layers. So because it is writable container, you can write onto a container, you can put all your images over this, you can install, you can get inside this container. So before I go to that topic, I will say that let's say you have built up this image within this container, and now this portion, you have nothing to do on this portion, the green portion that you can see on the container. Why? Because whenever you create a container, Docker will always put an environment within it. Because this environment is the core of running the container. Container is a dynamic object, like I said. You cannot run an image because image is a static object. You cannot run an image. Your application will not run unless and until your container, you have put that image into a container, and the container, once you have put that inside a container, only that time the image or the application is runnable. And who is helping the image to run? Not only the operating system, because operating system is also part of the image. It's static layer. It cannot run on its own. It needs some support from the kernel of the container. So you do not have to install this kernel, this C groups, namespace, device mapper. They are inbuilt once you have created through the Docker, once you have created your container. Is that clear? Any questions? So what is the green layer? This is the core, or this is the heart of this container, through which this is the kernel. Everything comes to the kernel. Kernel will direct or manage the devices and the image layers based on the C groups, namespace, device mapper. So basically, kernel will be helped by C groups. C groups is a very, very important term in Linux world. You will systemd. Have you heard the term systemd? System daemon, which runs in every.
Sorry, I just have a question. Sorry, in this container, is it that the maximum layers we can have is 4?
No. There is no limit. There is no limit. That's why it is dynamic. Its size of the container keeps on increasing as per the size of the images.
Okay.
The image can be 10 MB, image can be 10 GB.
Okay.
So the followed. So you can have Ubuntu layer, or say operating system layer, another software, Java application, the Java compiler, and on top of Java compiler, you will have web application, or say Tomcat or Apache, or you may have Nginx, whatever web server it is there. You can have middleware. You can have database as well. Database, say MySQL, as an image inside a container. And on top of it, you are having your Java source code, or the source code, maybe Python. So all of them will have sizes. Each of them, as you keep on adding layers, layer after layer as an image within the container, your size of the container will keep on growing. Okay. And if you are working on a very well organized architecture or platform, which is Kubernetes. Okay, so this container does not have any restriction of the size, because that will be managed by the orchestration tool called Kubernetes. We are also going to learn Kubernetes on the after Docker. We will learn Azure DevOps, and then we will go to Kubernetes 2 sessions. Okay, you will learn that. So I will not come to Kubernetes discussion, but the lowest unit or the micro unit in a Kubernetes is a pod, and pod is nothing but a container. Pod is another layer over the container that we will discuss in our Kubernetes session. But for the time being, as you have rightly pointed out, there are no restrictions. The restriction is only the capacity of your server or the node on which these applications are running. But those are architectural inputs. Your architect will be working on that. How much is the space, the namespace that you will allocate for your application? That is the calculation that will be involved. So you do not need to worry. As a DevOps engineer, you need to understand the mechanism of the building of an image and building of or creating of a container. How a container is running internally. So internally, is that fine? Did I answer your question?
Yes, I have another question. You made mention that the bootfs, which is the green part, is it that all the container will have that part?
Exactly.
By default.
Exactly. This is the common section of, you can have hundreds of containers in an environment, right? So hundreds of applications will be there. Microservices, we say microservices. So those can be running inside each of the container. Now, so the common part, this is not your part. We are not going to manipulate or handle this part. This is automatically whenever Docker creates a container, the Docker already creates this part as a common portion for each and every, whether the container is 10 GB or the container is 10 MB. This part is common part. It doesn't depend on the size of the container or how many image layers are there inside the container. It doesn't matter. This is the common function, because the C group is like, as I was asking, whenever you will learn Linux, if you are learning Linux from a competent through a competent channel, you will understand, you will go into that depth where you will understand that how is the kernel working internally. So there is a daemon that is running, which is called systemd for any Linux, whether it's a Red Hat or Ubuntu or anything. Okay, so that systemd is an OS kernel important component, systemd, which has to run. It is like the clock ticking. Without that clock being ticked, you're like in a laptop, you have your clock. Till the clock keeps on ticking, your laptop is on. Once the clock stops, that means your laptop will either have crashed or laptop will stop functioning. Similarly, it is the kernel will keep on till the systemd keeps on running as a daemon in the background. Here, we are not talking about the operating system. This is an environment that has been built by the container, by the Docker. And in this, it is, you can say, sort of a subsystem of an operating system, which will support the kernel to run or manage the resources. These are resources, isn't it? The images are physical layers. These are resources. So the resources have to be managed. Who will manage the resource? Kernel will manage the resource. Through what? Through you do not have systemd. Systemd will be there under Ubuntu. under the operating system, you have for containers, you have the C groups. So in Kubernetes, when we learn in our job ready training, that is the 2 months training of DevOps, you will learn systemd and how systemd will be converted into C group when we come to Kubernetes. Okay, but for the time being, you just do not need to go into that details. You just need to understand that C group is the resource manager. And the resources are isolated. That means, let's say you are having a solar system. Your Earth is one of the planets in that solar system, isn't it? But your Earth, Neptune, Venus, Mars, Jupiter, these are all the planets circling the sun. Sun is in the innermost, like in the core. So you can say the kernel is the core, and these are the various planets which are orbiting around the kernel, because these are one objects. These are planets. So these are resources. So the sun will never, or this particular, this is, let's say, Neptune, this is Earth, this is Venus. So will the Venus crash on the Neptune, or will the Neptune crash on the Earth? No, they are doing an orbit in their centrifugal motion, whatever the motion is around the sun. Similar is the case over here. I do not want these resources to crash upon each other or to conflict of resources. So each of these resources will have some requirement of the resources that will be managed by the C groups, and they are separated from each other in layers through the namespace. So are you getting me? So these are the internal mechanism, how you manage the resources of the image layers, as well as how you separate them, isolate them, such that they do not conflict with each other or interact with each other. They can operate in their own orbit. So to make them very, very secured, today I'm not using my pen that much, because what I observed, I take a lot of time in doing some explanations, and what I do, generally Mr. Menon is not very happy with me because I exceed my timelines, which would have taken me one session. I take 2 sessions for that. That is not good. That is good for you. It is also good for me, but not for Mr. Menon. Okay, because he has to go by a schedule. Are you getting me? So I'm using minimum use of pen today. But still, are you being able to understand that? How the mechanism inside the container works? Are you being able to see that? Understand that?
Yes, at
Yes.
least I can
No, thank you.
understand.
Sorry, there is something you namespace, isolate, and secure. What do you mean by secure them, sir? Please.
Secure them, that means that is they are working in their own orbit or in their place. So that means there is no clash between the image layers. Otherwise, what will happen? There can be a resource contention. There is a fixed amount of memory. There is a fixed amount of CPU, the process. So if everyone is encroaching into the other's private area, what will happen? It's as if you are giving a space. That's why it is called a namespace. So each layer will have their own space of operation. They will not encroach, or they will not try to grab the resources from the other layer. That is to secure them in their own place. That is an internal mechanism. I cannot do anything about it. That is the architecture, that is the design, and that's how your containers become very, very secured. The image, each of the image has its own purpose. A web server will not be similar to the operations of your operating system. Okay, so they will not encroach each other in their functions. There is no function overlapping, overriding. These are object-oriented programming concepts. You have to make the isolation of the objects. Isolation is a very important term in object-oriented programming or object-oriented architecture. Atomicity, isolation. Atomicity, isolation. These are the various important terms. Okay, so when I say object-oriented architecture. For a developer, it is object-oriented programming. Oops, you have heard this term. Okay, so one of the important aspects of object-oriented programming or object-oriented architecture is isolation. Other one is atomicity. Atomicity. And there are so many. You have polymorphism. But that is something else. I will not go into that details. Polymorphism, encapsulation. These are object-oriented properties, intrinsic properties. Okay. Now, so isolation being very, very important concept, you have to make your, that is, it should be loosely coupled. Loosely coupled means anybody can explain what is loosely coupled? This object and this object, they must not interfere with each others. They should not be tightly coupled. That means they will not have any dependency on each other. This is isolation. You have to do your isolation very carefully. You do not have to do anything. Basically, it is Docker, that the technology of Docker will help in isolating the images to secure them in their own place so that there is no encroachment on each other's resources. Because resource, whatever resource you have, memory, memory, CPU, okay, these are very, very valuable resources. You should not fight for the resources. The resources will be available to you in a manner that is a cyclic manner, but that will be only managed by the C groups and the namespace. You do not have to fight for each other. You should not grab the memory which is already being used. Otherwise, what will happen? This will crash. This will crash. So these are the various considerations that is already inbuilt. I do not need to worry about all those parts because those are not needed for our understanding. These are the basic understanding. Any software engineer will go through all this technology in their college level, in the university level when they are learning computer science. Okay, I do not need to go into that details. As a tool, as a DevOps engineer, I will need to concentrate on what is happening inside. How is not important to me is what is very important. Got it? So ultimately, what is happening here is your Docker image is like this 1 GB of a Docker image, which you can put inside any container, number of containers. So same image can run in multiple containers. You will create this container with this image. So these containers can have the same image. So I have a Java image, Java compiler. I can put that compiler in all of these 3 containers. all of these three containers, but the source code. So this may be the login application of Java. This may be the database application, or say the product catalog application of the Java. And this would be, say, the shopping cart application of Java. So they are based on the same image. So everywhere you have the Java compiler, Java compiler, Java compiler, Java compiler. Only your source code is changing. So therefore, these three containers are running three different applications, three different microservices, but with the base image all the same. What is the base image in this case? It is the, what is that? It is the Java application, Java compiler. So that Java compiler is the same Docker image, but available in all the three containers. Is that fine? That can happen. So you can have one image in multiple containers. No problem. But these containers, do you think they are of the same container IDs or container names? The name of your Docker image can be the same in the three containers, but will the container name be the same or the container IDs be the same? You cannot create two containers with the same container ID or with the same container name. That is not possible. Each of these containers should have a different or a unique label. Now, virtualization versus containerization. It is very common topic. I don't want to go into details, but yeah, I can say earlier, virtualization is the process of running multiple virtual systems on resources on top of a single physical machine. Now you have one laptop or one desktop, but you have three applications to run, and these three applications will be running on three different operating systems. So is it possible? So you need to have three laptops, one laptop having Linux, one laptop having Windows, and one laptop having Mac, because there are three applications. One will run on Linux, one will run on Windows, one will run on Mac. Is that good? Or if you have a facility of virtualizing your one laptop, you can virtually partition them into three laptops. Will not that be good? Yes, you can do that. So you can have a physical machine, physical platform, which you are dividing based on virtualization of the operating system. So what you are doing, you are partitioning the physical device into three devices based on installation of the full operating system on each of those partitions. So this will be Mac, this will be Linux, this will be Windows. So what you do, you install a hypervisor. Hypervisor can be VMware, Oracle VirtualBox, Microsoft VMware, VMware ESXi. All these are examples of hypervisors which are implemented on a bare metal operating system. So that way you have virtualized your machines, a single machine, the physical thing, with the three operating system, different operating system running in the same host operating system. You see, the host operating system remains the same. It can be Windows, it can be Mac, it can be Linux, doesn't matter, but you have partitioned it and installed as you think this is one server or one server. So there are three servers on top of a single server. That is possible through hypervisor or some virtualization software. But you have to do a full installation of the operating system over here, over here, over here. And you are installing, let's say, a Java application, maybe Python application, and this is, let's say, .NET application. Okay. So that is very, very important. This virtualization was happening quite a long time back, but that was a very useful tool at that point of time. But you have to install the full operating system, a full operating system. So the application with the full operating system becomes too large, too big to be portable. Just give me 1 minute. I will just off my camera. Just give me 1 minute. Okay, I'm back. So what we do is go back. So that is how you create, but this becomes, let's say this one is 1 GB, this one is 1 GB, or this one is 2 GB. So the entire application is like this. Whereas when you come with containerization is an OS level virtualization. So there is no OS. You have virtualized it. You have got rid of it. Okay, you have done that. Here you have done OS. You have to install the OS. But here you have done with an OS level virtualization is nothing but containerization. Used to deploy and run distributed applications without launching an entire virtual machine. So you are not creating virtual machines. You are creating containers. This is again an operating system, but only minimum of, because you have taken out the OS, you have given only the minimum amount of binaries and libraries, which will help and support your application. Let's say this is the Java application, this is the Python application, this is the .NET application. You are not restricted to any particular platform of OS. That is the beauty. Because if you go to the earlier, if you had seen that earlier diagram, where you dependent on that OS, you had the minimum OS, which is the Ubuntu or Red Hat or this thing as an image layer. But the base layer is still the container kernel with the C groups namespace. Okay. So that will help you to virtualize your OS. What virtualization means? You have got rid of the OS level. Here it is the virtualization of the bare metal. You have done the virtualization of the physical system. Here you have done the virtualization of the OS. The physical system remains the same. You have the hardware, you have the operating system, and then you install a container engine. Most probably it will be Docker. Most of the cases. You install the Docker engine and then your work is done. These are all containers. Small containers. If it is 1 GB, this is only 30 MB. If it is 2 GB, it is only say 80 MB. Can you believe you have not only containerized, you have given a lot of the resource is a very costly one. Resource, the memory, the CPU, these are the costliest part of any system. So you have minimized that cost because you have optimized the resources utilization. So instead of 3 apps, you can go for hundreds of apps, hundreds of microservices as containers. Are you getting me? Because you have optimized the use of your resources, the CPU and the memory. Clear? Containerization is the packaging of software code with just operating system, libraries and dependencies that are required to run the code to create a single lightweight executable called a container that runs consistently on any infrastructure. No infrastructure dependency. because it is running inside the container. So this environment is already inbuilt within the container. You do not need to worry about any external influence of any platform environment. No, you are insulated from that. Clear? No questions? Any question? If you are having no questions, I am happy at the same time, but I'm a bit worried that no questions can also be because you are not understanding. But I'm happy if you have understood that, and then we can proceed to the next slide. So it is just the simple thing, revolution in application deployment. With the advent of containerization, it is called, we have revolutionized the application deployment. Now we do not need to worry about platforms and their dependencies, and your deployment will crash because your environment is not compatible with your application. So many considerations were there earlier. Now it is not there. You do not need to work on this. See, this is virtualization. So your applications is so big because almost 70% of the space and the resources is occupied by the OS. Here it is this application and the minimum binaries and libraries. So this is a one container, another container. So how smart it has become. Okay. So your entire application is running inside these containers. So Docker images is couple of MB. So this is the Docker symbol, the logo of Docker. It is like there is a big story behind why you have adopted the image of a whale. If you have learned, if you have seen that movie, Moby Dick. So this was a Moby project. Moby Dick was a very friendly whale which used to guide the ships in Atlantic. When the navigation of the ship is lost, almost they have lost their path. So appeared a white whale called Moby Dick. Okay, this is a story. It's a fictional story. It was enacted by Roger Moore. I think not Roger Moore. Sorry, it was Gregory Peck. Gregory Peck is the famous Bollywood actor, and that was a very old movie, but it was a fantastic movie. So that project was taken by Docker, and they have adopted the shape of this whale because to commemorate that particular event or to that particular novel. Okay, so this is a very friendly whale which will help you to containerize your applications and take the containers to any port to deploy. These are very lightweight Docker images, whereas the virtual machine images are a couple of GB, very, very big. The speed, because of the size, the speed is very slow, whereas the speed is because it is very lightweight containers, it can start within seconds. And compatible only with the Linux distros, this is not correct because nowadays it is compatible with Linux, with Windows, with Mac. VM is of course compatible with all the OS. So all these three will be ticked for Docker. Here there are two cross marks. So this is for an example. If you see that you have a infrastructure and maybe any hardware, and then you have installed your host OS, which is a Linux. This is the Linux symbol of Linux, logo of Linux. It can be any Linux. It can be Red Hat, Ubuntu, SUSE, Fedora. And on top of it, you install your Docker engine. And after that, all is about containers. You build your containers with, you see, this is an Apache Tomcat, and you have a Java compiler. So your application is a Java web application. Similarly, here in this container, there is an SQL server, which is a database, Microsoft SQL Server, and there is a Microsoft .NET compiler. Okay, so you can see that this is a .NET database application. And then there is the Python, on another container, there is a Python and MySQL. MySQL is another database. So you say it's a Python MySQL database application. So in the same machine, you are hosting 3 microservices or 3 applications. One is a Java application, a Java web application. One is the .NET SQL Server application, and one is Python MySQL application, database application. Are you getting me? Any question? So before containerization, you had a lot of issues because you have to install each and every thing over here, Postgres, SQL. So if you had to install Redis, and then you have to be aware of the platform that you are installing. So if it is on Mac, you have to install separately. If it is on Linux, you have to install them separately. And therefore there will be installation process on different OS environment, many steps where something can go wrong easily. And we have seen that during the earlier days. There were lots of hiccups, there were lots of issues, because after all, you have to give that, the development team gives an artifact or instruction manual to the operations team, how to get the environment ready. But they are not technical guys like the development team. So there will be a lot of to and fro between the operations and the development. To get a simple deployment, it can take weeks. And after that also there can be issues, errors. And running, the operations manager will try to contact the development manager. Development manager is running away, because these development guys are very difficult to handle, because development manager is almost like me. I cannot handle that much pressure, so he's taking a leave. Whereas the operations managers are very proactive, and they work because they are the owners of the server, and the servers are directly interlinked with the client. The client is working on the servers, production servers. Who is responsible? Operations team. So the operations manager is much more responsible than a development manager, because the developments have their own way of doing things, but ultimately everything will be responsible. The operations guys are responsible with the clients. They face the music. Development team does not face the music. So they do not care whether they understand the environment setup or not. This is a reality. It is not that I'm trying to say anything ill about development, or I'm highly in favor of operations. Not that. It is a reality, hard fact. But so the entire thing after containerization, now everything has been smoothened out. So you are there as a DevOps guy in between the development and the operations. So what you do is say that, see, you do not fight with each other. I am there. I am giving you your solution. You do whatever you want to do, development, put everything, give it to me. I will manage that. I will make that into an image and put that into a container, and I will give that container, and I will give one instruction to the operations guy, just one line of instruction. That's all. They will be easily deploying the entire Java application as a jar, application source code, with all the dependencies inbuilt within the container. That's all. So my everything, I do not need to think whether it is going to run on Mac, or it is going to run on Linux, or it is going to run on Windows. Everything is taken care of with the help of Docker, with the help of containerization, with the help of creating the image. Everything is done. I will give that. I will give a Docker artifact like a Docker file, and they will have to run one command. It will run that Docker file. Everything is done and dusted. Is that clear? That is how you become very precious. You become an asset to the company as a DevOps guy. Are you seeing the importance of you being working as a bridge between the development team and the operations team for each and every project? Any question? Anyone? So the problems before container, and as I have already discussed that the problem was the environment. It was very, very difficult for because the developers are very intelligent. They can tweak their environment into adapting to their code. They are very fine, but this you cannot ask the operations team to manipulate their environment, because it is not only their program or their project is running. There are other projects running on the same pre-production server or production server. So they cannot manipulate the environment like what you say. It cannot be. Are you getting me? That is the biggest problem. So there will be a lot of back and forth. So what we said, that after containerization, here is the container I have wrapped my code in. So the developer is saying, with the help of the DevOps guy, I was able to wrap the entire code inside the container. And please have that. Wow, it's hardly 30 MB. Awesome. Your code works just fine, because see that 30 MB entire application now can be ported anywhere. It doesn't take much resource. They are very happy. And one more important thing is that the operations team do not have to tweak their environment. Nothing will change. So whatever the programs are running earlier, regression, there is no break in the regression. So what was running perfectly will still continue to run perfectly, even with your changes coming into the system. So the way we look at application deployment is changing, because we were looking at monolithic. Mono means one, and lithic means layer. One layer application. One layer application means all the modules, all the functions are tightly coupled within one layer. So if something happens over here, you cannot take it, you cannot plug it out to the rectification, do the rectification and then plug it back. No, for a single layer, you cannot do that. And you have to host that monolithic in a big server. So if something has to be corrected, you have to make the entire application down. Then once you have done the correction, you have to again build, you have to again test, and then you have to again make it run in that same environment. So it takes a lot of hard work. Whereas now, today, that was in this millennium, 2000, and beginning of this 2000, this decade, 2000 to 2010, this was happening. But after 2010, especially after 2012 and 13, when the DevOps came into market, you have given the Docker the privilege of having microservices. So this entire application is built up in microservices. If one of the microservices is wrong, you can take it out, do the rectification, put it back. No one is impacted. Nothing is impacted. You do not have to make the servers down. There is no downtime, because these are loosely coupled services. It can be rapidly updated, and you can deploy many small servers. You do not have to have a giant server like the IBM AIX servers. Okay. So therefore, it is very important that you can have very less potential servers but highly effective deployments. So they can host a lot of microservices, because it is called application modernization. The single application layer, now you have broken them into microservices. Each of them is an application. They are like loosely coupled. They are called microservices. Break application into separate operations. Though for a developer, you ask any developer whether building an application in a single layer, whether it was easier or building a microservice is easier. They will always say that building an application like with one layer is much, it is conventional. It is much easier than to build microservices. You have to follow 12 factor. So if you fulfill all these 12 factors, then only you can claim that your application is a microservices application. It is difficult, but once you have done it, it's a complex architecture, but once you have done it, you can assure that this is going to be run much more efficiently and cost effectively than an application which is running in a single layer. Is that it is maintainable? This is not maintainable. This is very difficult to maintain. It is a nightmarish sort of an application to be maintained. So application delivery, what do you mean by application delivery? You want to deliver your application. So you have to go through 3 stages: development, testing, and pre-production, that is staging, and then finally production. So up to this development to delivery to test, it is called delivery. And from test to either pre-production or production is called deployment. So if you can say that this is this part is delivery and this part is deployment. So what is delivery? You have a developer who has given all your codes, the source code you say, into putting it into a GitHub, maybe a version control software. It can be GitHub, it can be Bitbucket, it can be GitLab, whatever it is. Okay. GitHub, these are all DevOps tools: GitHub, GitLab, Bitbucket. There are many other version control tools. Okay. Now you have put that, and then there will be a build server. There will be a build server which will auto build your application code. These are the pipelines. These are CD pipelines. CD means continuous delivery pipelines. So there it will go through a build server. There can be a Sonar Cube which will which will see the quality of the code. Okay. So once you have, so the build failed. So what will it do with the artifacts? It will go back to the developer. Artifacts will suggest what failed, what has to be done. So all these things will go back to the developer. Developer will do the rectification, will again store it back. Again, there will be an auto build. And let's say this time the build was successful. So now if the build is successful, you will do Docker compose. Or better to say a Docker build. Docker build. So what you are doing, Docker build, you are building an image. You are doing an image. You are building an image of the entire code, entire application. Then you will put that image. You can deliver that image for, you have delivered that image for testing. And the testing is under the QA, quality assurance. Okay. So once that the testing has happened, now it will be deployed because you have done it as a container. You have done it as an image. So now you do not have to do anything manual. You will just deploy it to the pre-production stage. So this will be a pre-production server. You will have a UAT over there. This is over there. You will have a SIT, system integration testing. Here you will have user application testing. Okay. Sorry, acceptance testing. The user, who is the user? Can anybody tell me? Who is the user? User acceptance testing. So who is the user here in this case? What is the user we are talking about? Is the user your project manager or your operations team or your development team? Who is the user, or the testing team? No, the user is your client. The client will be testing from their end on the deployed product, which is on the pre-production. So once they give a green signal or a go ahead, it will be finally deployed into the production. It is now becomes very simple on the pipeline. You will just deploy the image. That is how we will learn the pipelines as well. From the next session, we will learn the Azure DevOps, which is a pipeline, how it works. Okay. Any question at this part? So up to testing is the delivery that you need to build, and then build an image through Docker. And then when everything is tested fine, you will, when they give a go ahead, you will deploy it to this is called deployment, because it is already an image. You just have to deploy it. Is anyone there? I'm not being able to see. Maybe there is no one other than me, but let's see. Let me complete. So the history of Docker, yeah. So March 2013, that is the red letter day or red letter year, whatever it is, say that Docker is released to the open source. From here starts the DevOps and containerization and your automation. Whatever DevOps is today is because of the year 2013. Huge market. So the Docker, as you have learned about this, there is basically, this is the architecture of Docker. You have a Docker server, okay, which will run as a Docker D. Docker D means daemon. It will run in the background. This is the Docker. The Docker engine is created of server, a REST API, and a command line interface. So it is like this. When you install Docker, basically you are installing the Docker daemon along with the REST API, along with the Docker CLI. So all these three components are installed when you install Docker. What will the Docker CLI do? Like the shell of a Linux. It is the kernel is the core and the shell is the topmost layer. So similarly, Docker CLI is the topmost layer. What will it do? You will write Docker commands, and those commands will come and get interpreted over the Docker CLI. So when these commands, but the Docker CLI cannot process the command. Like you have to manage the image, you have to manage the container. Managements you will create, you can run, you can delete, you can read, all this. These are management. So you can manage the image, you can manage the container, you can manage the network and the volumes, the space, the storage of the Docker images. All these things can be done. But how? You will write commands. That commands will be interpreted at the Docker CLI level. Okay, but it cannot communicate directly. The entire thing will be managed by the Docker daemon, the server engine. So what will it do? It will pass it on to the REST API. REST API is like when two applications call each other or communicate between each other, it is called an API call. This is one application. This Docker CLI is one application. When Docker CLI is trying to communicate with Docker daemon, it will take the help of REST API. So REST API is an interface between the two applications trying to communicate with each other. If you try to see the definition over Google, you will see what is an API and specifically what is REST API. Okay. Anyway, doesn't matter. You need to give the commands. The commands will come down to the server daemon, Docker daemon, to get it executed through the REST API. The REST API will take that call over there. REST API does not, it's like a postman. It will deliver the packages or deliver the instructions or the message from this application to this application. And once that application comes here, it will be converted into machine language, and it will then it understands how to manage the data volumes, image, container, network. Is that architecture in very short span of time? Is that clear? Any question you have about the engine and the architecture? So let's say the Docker workflow, how does it work? You on the client level, this is the entire Docker machine. Okay. You as a client or you as a DevOps guy, you will give these commands: Docker build, Docker pull, Docker run. These are the commands. Where will the Docker command come to? Just now we have discussed. Who will interpret your Docker commands?
The CLI.
Yes, exactly. Thank you. The CLI, the client, the Docker client, the Docker CLI will help you to, they will check, the client will check, the CLI will check whether your syntax is correct, whether the grammar of that command is correct. But it will not understand whether, yeah, it will just say that, yeah, your command, the syntax is correct. I will pass it on to where? Pass it on to the Docker daemon. Okay. The Docker daemon will receive it from the REST API call that the client makes to the Docker daemon with that particular command. So this command reaches the Docker daemon through the REST API. Okay, this is the Docker host. Docker host means the Docker engine or the installation, the Docker server on which you have installed the Docker. So the Docker daemon is running in the background as a daemon. Daemon is always like a job, that a service that is running in the background, not in the foreground. You cannot kill or you cannot stop that daemon unless until you know that command. So what will the Docker daemon do? So let's say you have, this is I think the image of CentOS. CentOS, yeah, operating system. This is the image of, can anybody tell me what is the image? This is a famous image, logo. What is this called? Nobody? I thought this is a very famous logo. This is CentOS. That is fine. It's not that popular, but this is a very, very popular. You must have used it. This is Ubuntu. Ubuntu Linux operating system. This is Redis. This is Nginx. So these are various images stored where? This is, as I was telling you, this is what? This is what? This is the Docker. Anyone?
Hub.
Yes, fantastic. Docker Hub. The hub means the registry where you store, like the GitHub. You store your source code. Source codes are stored. Similarly, here you store the Docker images. Docker images. Okay, this is one Docker image. This is one Docker image. There are there are thousands and thousands of images. You name it. You can have Oracle. You can have Windows. You can have Mac. You name it. Everything is available there. You can have MySQL. You can have PostgreSQL. Okay, so many things are there. So one of the images you wanted to download. So you have given a Docker pull command. That command will go to the Docker daemon. Docker daemon will go to the registry. If it does not find in the local server that image, so it will go to the registry, to Docker Hub. It will pull that image. So let's say you have pulled in Docker image called Ubuntu. So this is maybe you are treating as one layer. Remember, we have learned about layers, image layer 1. So this is the base layer. So at least one layer you need to create a container. So you have just pulled in your image and put it. So simple. In our job ready training, you will learn the commands in details and the various architecture. But here I have no scope to go into that details, but I'm just saying that the flow is you will pull that image and put that into a container. So the container is now running. It is runnable. So what it is running? It is running Ubuntu. So you say that this is an Ubuntu container running Ubuntu operating system. And on top of that, you can go inside that container. Now you can go inside. Once the container is physically available, you can go inside the container and then you can install many other layers. Let's say you can install Apache. That will be second layer. Then you can install Java compiler. That is the third layer. Then you can install say Node.js. Okay, so one application server or application server. Yeah, you can say that. Okay, and then you can have install all your Java source code. You can take all the Java source code. So how many layers you have built inside the container? How many layers did you build? One. This is 1. This is 2. This is 3. This is 4. This is 5. So the container size keeps on growing as and when you are installing the various layers. Is that very difficult? I don't think so. So you have created one container with this application. So your application is running over here in this container. You can replicate this container such that in case this container goes down, this will take over. In case this goes down, this will take over. In case this goes down, this will take over. We will learn in Kubernetes how you do the replication. Okay. This makes a very, very interesting topic because this makes your fundamentals very, very clear. And without this, you will not be able to progress. Even if you think of DevSecOps, whatever assets that you are building today in DevOps, tomorrow your company will ask you, Debasis, I'm very happy that appreciate your effort in building the entire automation pipeline and the various assets that you have created. Now tell me, how safe are they? Now then your knowledge of DevSecOps, or rather the security aspect of your DevOps assets, resources that you have created comes into picture. But unless and until you understand or you have built that knowledge of DevOps, you will not be able to graduate yourself to the next level, which is your DevSecOps or cybersecurity. Am I clear? Or the cloud security. So you need to understand all these terms. So I'm not going to go into the details of the various components. So one is the Docker Hub. You see, you pull from the Docker Hub, you go to the Docker engine, then from the Docker engine you will build the container with the pulled image, and you will add layer after layer after layer, and then you can run your container, you can stop your container, you can delete the container, you can manage your container. There is that is what Docker Hub is. The Docker Hub is the place where you store your images. Then the next part is the Docker engine. Docker engine, as I told you, they composed of three parts: Docker CLI, REST API, and the Docker D, which is the Docker server, which runs in the background. Now, without this, you will not be able to do anything, manage anything of the Docker images, containers, volumes, and all the stuff. So next comes the Docker images. We have all been talking about Docker images and containers. So the next thing is the Docker containers. You see what is a Docker container. Then comes the Docker volumes. These are the various Docker components. Docker volumes. Docker volumes are nothing but Docker itself. Docker containers cannot persist data. You know, persist means, anybody having an idea of persistence? Docker containers are ephemeral in nature. What is ephemeral?
Temporary means that.
Fantastic. Temporary. So Docker, my pen is not. Docker containers are ephemeral. Ephemeral is temporary. Temporary means like our RAM, random access memory. What does that RAM do? RAM can store your data, your whatever the variables and the values within that in a very temporary arrangement. Very temporary. Once you come out of your system, your session goes off, your entire thing will be wiped off. Similarly is the case of once you try to you can work with the temporary variables and data, but once the container is down or you shut down the container, your data is lost, gone. So Docker has given you Docker volumes. Docker has given you Docker volumes. Okay. Docker volumes are actually your storage, persistence. You can store your data, and without even the Docker container goes down, Docker volume does not go down. It is like a hard disk. Your laptop is gone, but your hard disk is still there with the data. So you can retrieve your data. Similar is that concept. The last thing is the Docker file. Now, Docker file, remember we have said about the manifest file or the artifact which you give to your testing team, and then you ask them to run a particular command on that Docker file, and the containers with the images are created. That is a YAML file. Okay, so you will have to write a Docker file. That in details we will learn in our job ready training. Not this is not a part, or we cannot do it in the scope is limited in these sessions. Okay, so basically you try to remember this is a file which can be executed by Docker command, and that will help you to build an image, and that image you can put into a container, and that you can store it over your Docker Hub to be used later on. So these are the components of Docker, and I think we have done enough of this thing. And there is no scope for me to go and show you a demo on Docker. If I had time, I could have done, but let us make an end to this Docker. We will see. On the next day, we are going to start with what? Azure DevOps. So remember, we are going to start with Azure DevOps. We have completed introduction to DevOps. We have completed both the sessions we have taken for AWS Cloud. Then 4 and 5, we have devoted these 2 sessions for Terraform. And then 6 and 7, we have devoted for Ansible, another very useful what is that? DevOps tool. And if you are saying that you have missed all these sessions, maybe you can go into our YouTube channel and you will get the link in our group in the description, in the pinned message, and you will go to YouTube, you will find all those recorded videos for these sessions. So you will get 2 videos for AWS Cloud, 1 video for introduction to DevOps, 2 videos for Terraform, and 2 session videos for Ansible. And today we are going to load the 8th session, which was Docker. Next 2 sessions. Now this is also going to be uploaded into YouTube. It will take 1 or 2 days. After that, I will also post that video in the groups. Then 9 and 10, we will devote it for Azure DevOps. Which is the CI/CD pipeline. And this is one of the. Hello, Shekhar? Are you sharing something? Hello? So Azure DevOps CI/CD pipelines for 9 and 10, and then 11 and 12. See, I was supposed to only have 8 sessions. Now it is not good, or maybe it is good for you. So 11 and 12, we will do Kubernetes. So we have 1, 2, 3, 4 extra sessions. That's okay for me, if you are fine with it. Or would you like me to stop over here? 8 sessions done. Stop over here. Shall I take this 9, 10, and 11, 12 in the coming 4 weekends?
Please, Mr. Debasis.
You tell me.
Yes, please.
Are you sure? Are you going to join?
Yeah, I'm so interested.
Okay, very good. And because these are very much in demand, Azure DevOps, Kubernetes, whenever, even if you are going for a DevSecOps or cybersecurity interview, they will ask about all these things. You cannot avoid. And that is a practical experience we are seeing from our students. They are going for interviews. They have done DevOps as well as they have done DevSecOps. Few of them have done only DevSecOps, or rather cybersecurity, and they are facing a lot of struggle because when they are appearing for cybersecurity interviews, they are getting lots of questions on DevOps. So who have done DevOps and DevSecOps, both of it with us, they have benefited a lot. And you can get this. Selassie can always tell you about that. Selassie, if you are there, can you?
Yeah, I mean, I actually went for a DevSecOps role interview 3 days ago, and most of my questions were DevOps. They barely even touched on security. It was more questions about Terraform, Docker, AWS. Just because this company was migrating everything on-prem Instructor framework to AWS. So their questions were about Docker, Terraform, Kubernetes, and AWS. So it's the questions on DevOps more and more. They're looking for somebody who could do it all. So more and more is a lot of DevOps questions. And I think they assume that most people doing the DevOps are coming from security, so they want to make sure you are really know your way around DevOps and of course security, but more than anything DevOps.
Exactly. That is because the trends are changing. Earlier, when you were getting interviewed on cybersecurity, they will restrict only on the cyber security topics, DevOps, DevSecOps. But generally, this will keeps on changing, and the interpretation of it depends on the interviewer how they look at judging a person. But it is gradually it is very clear, getting very clear that it is good that if you start with DevOps and then graduate to DevSecOps or cybersecurity, it is the best path. So in our Kubernetes demonstration, there is one page, one thing that is the ideal path, how you graduate. So that in that roadmap, we will see that you start with DevSecOps, DevOps, then you go to SRE, and then you go to cybersecurity. But in between, you may or may not go to SRE. But we will see that when we come to Kubernetes. So today I will end here, and it is all over to Mr. Menon. If you have any questions, please let us know. So, Mr. Menon, I think we are end of the session.
He probably stepped away from his computer.
Sorry?
I'm saying he probably stepped away from his computer.
Yeah, maybe. So fine. Today we end the session over here. It must be very, very tiring. 4 hours at a stretch is not a matter of joke, and I will not burden you with any further details. There's a brain has a particular capacity. After a point, it does not take anything.
Exactly, and those two sessions is really impactful, and it is not like we are, you, Mr. Karthik, deliver so much information, and it is really sometimes it feel tiresome for myself as well. So guys,
Yeah.
I think it is it is a good time we can wrap for this weekend session. And if you have any question, doubt, feel free to ask. Our DevOps evening US batch is going to start very soon. I think most probably next Friday or next to next Friday. If anyone wants to interest to and pursue their career as a DevOps engineer, feel free to join and ping us in the group. Trust me, this is a one-stop solution where you can become a DevOps expert within next 2 months. And many of our students consulted in last 40 batches, they done the training and eventually they land their job. Okay, it is there is no hidden tricks. Only thing is you need to do the practice, and it will give you all like sorts of labs, live project where you can make your hands dirty, and that thing is going to pay you while you are in the interview in front of the interviewer, because that time they are not going to ask some theoretical question, they are going to ask some of your previous project experience. So that's the reason this kind of hands-on live training is more essential than 4 years of your study, better to say. So this Friday, last Friday, our cybersecurity classes for 2 months. I was started Monday to Friday, daily 2 hours, and it is going to continue for next 2 months. And DevOps session is going to start from next Friday. If you have any question, feel free to ask regarding our free classes, paid classes, job related question. You are most welcome to ask those questions.
Sorry to interrupt. Hi Paul. I joined late, I think. So next class when is happening? Like this free demo class or
Every
what?
every
Next
Saturday.
Saturday.
Yeah,
Every
same time.
Saturday. Okay. So
Next
just
Saturday.
want to clarify you. I'm into non-IT background, but I'm a BC computer science graduate. But way
Okay.
before, I have a non-IT experience of 11.5 years in marketing. So it's all working in an IT company only. So one of my neighbors
Okay.
suggested to learn DevOps, and then I'll try to refer you in his project itself. So, but again, it's he will refer as me as fresher, I think. What is your ideas and thoughts about this? So can
You will
Are you
refer.
based out of India or US?
I'm based out of India. Yeah.
Okay. Now, can you just repeat the question one more time because I lost somewhere.
So one of my neighbors suggested to learn DevOps so that he will refer me in his company, in his project itself. So I'm not sure he will refer or not, but I am having a non-IT background. I am into marketing. I worked for two companies. It's IT companies only. So that's I need some clarification if I learn DevOps. Maybe it's
Yeah, see,
again I need to
learning
start.
is, I understood.
Mhm.
So there's two, things related to get a job. One is preparation, one is, reference. In US, it is much more easier for people whoever are non-IT or IT because they don't
Mhm.
charge. They only
Mhm.
care about are you capable enough or not. Okay. If you have the
Okay.
hands-on experience, they are going to hire. But Indian
Mhm.
scenario is little bit different. They always, wants to know what is your past, but
Okay.
and that's the reason you need some reference, and I am
Mhm.
assuming your neighbor will going to help on that. But in
Yes.
terms of preparation, yes, it is. if
Mhm.
if you are take non-IT people, IT people, it doesn't matter because most of our
Okay.
classes is start from very scratch. Okay.
Mhm. Okay. But again, yeah, I am into CRM, customer relationship management. I worked for
We do have
almost
many
11.
people. We had
Mhm.
many people who are not at all IT engineers. For you had a
Okay.
degree
Mhm.
on your computer science, but those people they don't had any idea in
Mhm.
non-IT, like IT, and then eventually they successfully land on a job. But here,
Okay.
my session will be just join this free session. Don't go for the paid session, and
Okay.
one or two session. Then if you feel that okay, the but the problem with this
Mhm.
particular session, Mr. Debashish has already completed 7 batches, like 7
Mhm.
sessions. So
Okay.
it is you are joining in the middle of thing. Maybe so many things you are fly
Mhm.
above your heads. Don't worry,
Mhm.
continue, and it is not a rocket science, right? You done
Yeah.
your engineering, so you do have certain IQ. I can and it is only the reasoning and analysis,
Okay.
nothing more, nothing less. Okay.
Okay. Again next week, Saturday at what time?
Same time.
Same time around 9 p.m. IST or
Yeah, more or less.
okay.
Because there are 4 session, two session.
Mhm.
One session is happening in Friday for data science and AI. This Sunday,
Okay.
Friday, Saturday morning for you, and the and next 2 session is cyber security and DevOps. That is Saturday evening for you.
Okay. Oh, I'll try with Saturday evening. Yeah, 9 p.m.
Okay,
IST. Yeah,
sure.
sure. Thanks.
Thank you, everyone. Thank you all for this, and thank you especially Mr. Devashish for this wonderful session.
Thank you. Thank you all for your patience.
Oh, by the way, Mr. Mena, I sent you a text. Um, I'll If you can, when we get off, if you can hit me back so that we can have a conversation.
Is it Selassie?
Yes.
Can you ping me one more time? I could not find.
Okay. Okay. You got it?
No. Okay. Maybe because of this. Okay. Just ping. I ping you.
Oh, okay. Okay.
Okay. Thank you, guys.
Okay. All right. Thank you.
Thank you.